a graph trapezoid has two right angles so that these two sides are perpendicular to this side here. We call this side the base of the graph trapezoid. We call these altitudes. Okay? I'll put quote marks around these. And call these graph altitudes. This one and this one. Okay, now the question is, how can we reconstruct this trapezoid into a rectangle? Okay, well, there are actually two ways to do it, and we've been over this several times. You had several opportunities to do it. If I divide the trapezoid down the middle, in other words, if I find the bisector of the base and draw at a right angle here, okay, that's going to cut the trapezoid through the halfway point of the width. Okay? Now, if I take this part and lift it up here, if I cut along this line, take this part and lift it up, turn it over, and set it down on this part, well, I'm going to get something very much like this. Okay? And now this is a rectangle. So here's a rectangle whose area is the same as the area of the trapezoid. So I'll say that's a rectangle, area the same as that of the trapezoid. Okay, there's another way to do this. And let me do this with a different color. Let's go with purple. Okay. Another way to do this is I still have this line up through the middle, starting at the middle of the base, starting at the bisector of the base, moving up perpendicular till it intersects the sloping line here. I'm going to make a cut here. Okay? If I cut here, I've got a little triangle. Now, what could I do with that little triangle if I take it away to make what's left into a rectangle? Well, I take that little triangle and I turn it upside down, and I get this. Okay? The triangle fits here in such a way as to make another rectangle whose area is the same as that of the trapezoid, and therefore, of course, the same as that of this rectangle. Okay, now this is the rectangle we're going to want to think of in terms of the graphs. And incidentally, if you can think of a third way to make a single cut that allows us to rearrange the trapezoid into a rectangle, please let me know about it, because I don't know of a third way. I haven't absolutely proven that there isn't a third way, but I think that'd be fairly easy to prove, and that might be another interesting question for somebody to think about, just using what you learned or should have learned in a geometry class. Can you prove that there are only two ways to do this? That proof would probably go a little beyond the scope of a solid high school geometry class. But it would be in reach of somebody who did a good job in a good high school, in a high school geometry class that had the rigor that a high school geometry class ought to have. Okay, well anyhow, here's another rectangle. and its area is the same as that of the trapezoid. That's the purple rectangle. Just a quick indication of the geometric argument that proves that this rectangle has the same area as the trapezoid. This line here, I didn't state it, but it's implicit that this line, this cut is made at a right angle to the vertical side, to the graph altitude. If I extend this line over to here, then it makes a right angle here as well. Now, I don't really have room to write it, but I've kind of indicated the angle here and the angle here are the same because it's simply a transversal of, alternate interior line, alternate interior angles of two straight lines. This distance and this distance are the same because of why? Because this point is the bisector of this segment, and all three of these segments are parallel. And that's a very simple argument that'll show that this side is equal to this side. And of course, this angle is a right angle. This angle of this triangle is a right angle. And this angle here, well, it's actually in the triangle. It's clearly a right angle. And you can see why those angles are right angles. So what we have is we have two angles and a side of this triangle equal to two angles and a side of this triangle, showing that this triangle is congruent to this triangle. Therefore, this triangle has the same area as this triangle, and removing this triangle here from the trapezoid and then adding this triangle here, which is congruent to this triangle, doesn't change the net area of what we have. So that's an argument that you should understand rigorously, and if you don't, then you need to maybe think about increasing the rigor of your understanding of geometry, because I don't believe high school courses now require the ability to make that sort of an argument. And it's really important to be able to make that sort of an argument if you're going to use mathematics in your profession.